6.1 Solve linear systems by graphing. System of linear equations. In other words, linear system is two or more linear equations in the same variables. So an example would just be x plus 2y equal to 7 and 3x minus 2y equal to 5. The solution of a system of linear equations is just a coordinate xy that satisfies each equation in the system. Note, a linear system that has exactly one solution is called a consistent independent system. Because the lines are distinct and intersect. There are many different methods of solving a system of linear equations. The first method I'm going to show you is called the graphing and check method. So the first step you would do is to either use a slope-intercept form or find the x and y intercepts to graph. And then you need to identify the coordinates of the point of intersection. This would be your solution. But before you finalize your answer, you still need to check the coordinates algebraically by substituting into each equation of the original linear system. So let me show you how to do this. Guided practice, part A. Tell whether the ordered pair is a solution of the linear system. So for this kind of problem, it just gives you the solution for -2, and it wants you to determine whether it's a solution for both of these equations, which make up the linear system. So basically, this is step 3 of solving a system of linear equations. So first I'm going to plug in 4, -2 into the first equation. I'm going to work it out here to the left. Half times 4 minus 3/4 times -2. And we're going to see if this equals to 7/2. So when we simplify 4 and 1/2, we get 2. Let's take care of the signs. Negative, negative makes positive. And simplify 3/4 times 2, get 3/2. Okay, I'm going to continue my work here. So I'm going to rewrite 2 as 4/2 plus 3/2. And this apparently equals to 7/2. So it is 4 -2 is a solution for the first equation. Now we need to check the second one. So I'm going to work it out here. 4 times 4 plus 3/8 times -2. And let's see, will this equal to 61/4? We need to find out. 16 plus -6/8. Okay, and this equals, let's see, I could do 64/4, which equals to 16 here, and this would be -3/4 when it's simplified, and this will equal to 61/4, and this does equal to 61 = 4, so for negative 2 is a solution. So I'll just write yes. Part B. Solve the linear system by graphing and then check your solution. I'm going to use x and y intercepts to graph. So when x is 0, y here will be negative 22 over 8, and I will need to simplify this. Negative 11 over 4. So this will be my y-intercept. And then when y equal to 0, for the first equation, x was simply equal to positive 22 over 5. So your x-intercept will be 22 over 5, 0. And for the second equation, I'm going to also find the x and y intercepts. So when y is 0, x will be positive 9 over 2. And when x is 0, y will be negative 3. So now you have an x-intercept of 9 over 2, 0, and a y-intercept of negative 3. Okay, so now I'm going to start graphing. So negative 11 over 4 is also equal to negative 2.75, and 22 over 5 is equal to 4.4, and this will make it easier for me to graph. So negative 2.75, it's about here, and 4.4, I'm going to connect the dots. I'm going to label my x and y intercepts. And then I'm going to graph my other line. So this one will be 9 over 2 will be 4.5. It's about here next to 4.4 and 0, negative 3. I'm going to connect these dots. And label the x and y intercepts. So this will be 9 over 2, 0, and this will be 0, negative 3. Okay, so as you can see, the point of intersection is at 6.1, but you must be wondering, well, is that true? So then you need to check your solution. So I'm going to work it out to the side here. So your first equation was negative 5x plus 8y equal to negative 22. I'm going to substitute 6.1 in to see if it works. And apparently, negative 30 plus 8 is negative 22, so it does work. And then we'll have to check the other one. So equation is 3y minus 2x equal to -9. Okay, so your y coordinate is 1, x coordinate is 6. 3 minus 12 gives you -9, so it also works. Okay, for the next one, I'm going to also use the x and y intercepts to graph, but first I'm going to simplify my equations by getting rid of the denominators. So between 4, 4, and 2, the LCD is 4, so I'm going to multiply every single term by 4. So this will become 3x plus y equal to 26. And then, when x is 0, y is 26. When y is 0, x is 26 over 3. And then I can rewrite this as 8 2/3. I'm going to use this to graph later because it's easier to see. Okay, now we're going to look at the second one. I'm going to multiply the entire equation by the LCD of 4 and 2 and 1, which is just 4. So this would be 4x minus 3y equal to 26. And then I can find the x and y intercepts. When x is 0, y will be negative 26 over 3. And then negative 26 over 3 would just be negative 8 2/3. And when y is 0, x would be 26 over 4, and then we can simplify that to be 13 over 2, and we can rewrite that as 6.5. Okay, so I recopied the points here, and we're going to have to graph both of these equations. So for 0, 26, I'm going to have to plot it about here. I'm going to label it 0, 26, and then 8 2/3, it's about here. So I'm going to label that. And then we have 0, negative 8 2/3, that's about here. So we're going to put 0, negative 8 2/3. And then 6.5. Okay, so now we can connect our dots. As you can see, the point of intersection is around 8, 2. And you might be speculating, well, 2 for sure. Is that really true? Because it's just an estimation. So this way we really need to check. Okay, so let's see. 3/4 times 8 plus 1/4 2 times 2. So basically I recopy the equations here to the right and cancel this out. 6 plus half equals 13 over 2. Let's see if that's true. It is 13 over 2 equals 13 over 2. And then the other one will be 8 minus 3/4 times 2 equals 13 over 2. And then I can rewrite this as, let's see, 16 over 2. This can be simplified. So this will be 3 over 2. So we have 13 over 2 equals to 13 over 2. So yes, 8 over 2 is a solution of this system of linear equations. Word problem. With a minimum purchase of $25, you can open a credit account with a clothing store. The store is offering $25 or 20% off of your purchase if you open a credit account. You decide to open a credit account. Should you choose $25 or 20% off of your purchase? Explain. So I'm going to use a system of equations to solve. First, I'm going to define my variable. X will be the purchase amount, and Y will be the amount that I'm going to actually pay after the discount. Okay, and to represent the $25 off, I would take Y equals to X and subtract 25. And for 25% off, I'm going to use Y equals 0.80X. So 80% of the amount that I purchase will be the actual amount that I pay. Okay, so I need to first find the point of intersection between these two equations. If I were to use the graphing method, it would be very difficult to find that point of intersection. So I'm just going to show you a method and go and solve for x and y. Since this is y equal to and y equal for both equations, I can just set them equal to each other. X minus 25 equals to 0.80x. And then I can solve for x. And x would equal to $125. And y, I'm just going to use one of these equations to find my y value, 125 minus 25 will be 100. So my points of intersection will be 125, 100 on the graph. Okay, I'm going to show you a quick sketch of what this picture looks like here. First, set my increments. So maybe I can say this is 50. I guess that this be 100, 150, and so forth. And the other one, can let this be 25, and this could be 50, 75, 100, 125. So I'm going to plot that point of intersection. Okay, so the plot for y equals x minus 25, it's about here. Y-intercept at negative 25. Okay. And we just ignored this part of the graph. And for the other one, y equals 0.8x, that's probably around here. Okay, and by looking at this graph, you should choose $25 off if your purchase is less than $125. Why? Because this part of the graph shows me that the actual amount paid, actual amount paid for the $25 discount is less than the actual amount paid for the 20% discount. On the other hand, you should choose the 20% discount if your purchase, remember the x-axis is the purchase, is more than $125. Because according to the graph here, if you pay more than $125, the amount that you actually pay, for example, $300, let me work it out here. So if I use $300 as the purchase amount, okay, so 300 minus 25 would just be 275. And this will refer to this graph. And if you take 20%, so that would be 80 over 100 times 300. So as you can see, the amount that you pay taking the 20% off is less than the amount that you pay if you only take that $25 off. So that's why you should choose the 20% discount if your purchase is more than $125. So this is a numerical example. So if you plug in any points here for the purchase amount, it will be the same. Okay, I would like to make a note that I should have crossed this part of the graph out because I'm not working with any negative values because this is a real life example. And this concludes our lesson.